Hi students, in this video I'll be going through the 2018 O-Level Additional Mathematics paper 1 question 7. Alright, so this is a question regarding rates of change. Okay, so let's read the question. So they say that water is poured at a constant rate of 18 pi cm cube per second into a hemispherical bowl of radius 12 cm. Okay, when the depth of water directly below the center is x cm, the volume V cm cube of water in the bowl is given by the following formula. Okay, so in part 1 of the question, they want you to find the time taken for the depth of water directly below the center to reach 9 cm. Okay, so no diagram is given in the question, so I've drawn this hemispherical bowl. So it's actually recommended that if no diagram is drawn, okay, you can just draw a simple diagram to help you yourself to visualize the question better. Okay, so let's try to put this info, okay, understand this info better before we start solving the question. Okay, so water is poured at a constant rate of 18 pi cm cube per second. So this one is actually dV dt, right? Okay, because it's volume per unit time. Right, so they are saying that now water is going to be poured into the bowl at this rate. Okay, dV over dt equals to 18 pi cm cube per second. That means for every 1 second that passes by, okay, 18 pi cm cube of water is going to go in. And as water starts to go in, right, then the water level in the bowl will start to rise. So initially the water level is 0, okay, which means that the depth of water initially, right, okay, when time is equal to 0, the depth of water is actually 0 cm. Okay, so there's no depth in water. So as the water goes inside, the depth will start to increase. So as time passes, x will start to increase. Okay, so x will get bigger and bigger. And when x gets bigger and bigger, then the volume gets bigger and bigger. Right, so they say that at any particular time, the volume in water, okay, we can actually represent, okay, so the depth here, so there will be some water inside, right, okay, at any particular time, okay, so I've not drawn this very nicely, okay, but this depth, directly below the center of the bowl, right, okay, so this is the center of the bowl, okay, so directly below it, okay, this depth from here to here, okay, the depth of water in the bowl, right, will actually be x, okay, represented by x, right? Okay, so now in part 1, they want us to find the time taken for the depth of water directly below the center to be 9. Okay, so in order to find how much, you see the water is going inside the bowl at the rate of 18 pi cm cube per second, right? So in order to find out the time that is taken for the this amount of water to enter the bowl, right? We need to find out at this, when x equals to 9, how much water is inside the bowl. Okay, then after that, we will just take this volume of water divided by the rate at which it's poured in. Then we will be able to find the time already, okay, taken for the depth of water to reach this x equals to 9 cm. Okay, so what we will do now is we will substitute x equals to 9 into the formula. And this will allow us to find the volume of water. And once we know the volume of water, we just divide by 18 pi, we will get the time taken already, right? So just like this. Okay, so let's solve it. So when x equals to 9 cm, okay, the volume is going to be 1/3 pi 9 square 36 minus 9, right? Okay, so we're going to leave the answer in terms of pi. So if you calculate this out, you will get 729 pi cm cube. Okay, that means when x equals to 9, there's 729 pi cm cube of water inside. Okay, and every second 18 pi goes inside. Okay, so how long will it take to have 729 pi cm cube of water inside? Okay, so the time taken will be 729 pi cm cube divided by the rate at which water is being poured in. Okay, so this will give us the answer of 40.5 seconds. Okay, so you can see that at this point in time, we have not really made use of any concepts related to the connected equation yet. Okay, so it doesn't mean that it's a rate of change question. That means in every part of the question, you need to use the connected equation. Okay, so basically what you need to do is you need to understand the question well. Okay, what is the question all about? Okay, what is it asking you to find? All right, then you will be able to solve the question successfully already. So actually, it turns out to be easier than what you think it is, right? Okay, let's move on to part B. Okay, now they ask you to find the rate of change of depth. Okay, so if you recall, look at the question. X is the depth of water, right? So in other words, they are asking you to find the dx dt, right? They are asking you to find dx dt below the center at this time. At this time, x is equals to 9. Okay, so like all rate of change question, I recommend that you summarize the entire question into one statement. So now they want you to find the rate of change of depth. Depth is now x, right? So they want you to find dx dt. So in other words, they want you to find dx over dt when, okay, what is given to you. The next thing you will need to write down all the things that are given to you. Okay, so don't forget that we have been given dv dt, which is 18 pi cm cube per second. Right, so when dv over dt equals to 18 pi cm cube per second, and at this time, kx is equals to 9 cm. Okay, so this is the info given to us, and this is what we want to find. Okay, so next thing to do is always to write down the connected equation. So what we want to find, we put on the left side. What we already have, we put here. And then we ask ourselves, okay, what must you multiply to dv dt to get dx dt? So we need a dx on top, right? So this will be dx. And we don't want dv, okay, inside the expression. So we will put dv here, so that dv will cancel away, and we will have dx dt on the right side also. Okay. Okay, so we already know dv dt. So what we need to do is now is to find dx dv, right? So if you recall, look at the question. Okay, they have already given us the equation for v in terms of x, right? So 1/3 pi x squared over times 36 minus x. Okay, so now we need to differentiate this to get dv dx, and then dx dv will just be the inverse of dv dx only. Okay. Okay, so you may be tempted to try to use the product rule here, which you actually can. Okay, but for a simple expression like this, I would recommend you just open the brackets first before you differentiate. Okay, so 1/3 pi x squared times 36. So 36 times 1/3 will be 12 pi x squared. Okay, then 1/3 pi x squared times negative x. So it's negative 1/3 pi x cubed. Okay, so I recommend you do this first, then you just differentiate. Okay, it will be easier actually. Okay, so differentiate here, 2 goes in front, so you get 24 pi x. You see 3 times 1/3 will just become negative 1. Okay, so negative pi x squared. Okay, then from here you can actually just factorize out the common factor, which is pi x. So you get 24 minus x, right? So this will be your dv dx. Okay, so now that we know dv dx, okay, we can put everything into the connected equation. Okay, so let's do the working here. So connected equation is dx over dt equals to dv dt, okay, which is 18 pi, 18 pi, right? Okay, multiplied by dx over dv. Okay, so dv over dx is this. So dx over dv, all you need to do is just invert it. Okay, so you get this. Okay, so multiply by 1 over pi. Okay, now x is 9. Okay, so if put 9 here, then 24 minus 9. Okay, so you get 18 pi times 1 over pi. Okay, so 9 times 24 minus 9 will be 15, right? So 15 times 9, you will get 135. Okay, so actually I should write, okay, just write the 135. Okay, so the pi will cancel off. So in other words, we will get 18 over 135 lah. Okay, which you will simplify to 2 over 15, right? So this one is dx over dt, so cm cubed per second, right? Okay, so actually this one you may not need to multiply that. You can do this way also. 18 pi 1 over pi, right? Okay, so 9 times 15. Okay, so you will get cancel with the pi, 18 over 9 times 15. Okay, so the 9 and the 18 will just cancel, so you get 2 over 15. Okay, so you may not need to compute this 135 in the first place. Right, so this is how you solve the rate of change question. Okay, so the key thing for this question is in part one, okay, some of you may get stuck and ask yourself what are they trying to ask me to find, right? Okay, so you actually don't have to involve any connected equation, just have to understand what the question is asking, and then it actually turns out to be a rather straightforward and simple question. Okay, then the next part is the typical type of question whereby you need to use the connected equation, right? So actually it's not too difficult.